So pages 666, 667. You can start on page 666, and we're going to be looking in particular at how to use identities to solve trig equations. So we write some strategies down, and we've done some of these strategies already. We've used strategy number 1, write an equation with only one trig function. We've used that in our last unit when we used the hint, use sine squared theta plus cos squared theta equals 1. But we're also going to do that with double angle formulas. Sometimes you won't be able to write an equation with only one trig function. And so you might have to factor out a common factor. There might be an equation with a sine and a cos, but you can factor out a single. And last strategy is, again, in a solving equation, you can change things to sine theta and cos theta and eliminate any fractions. It is a solving question, so you can get rid of fractions. So we're going to look at a number of examples that you have to use identities for solving. So here's our first example. Solve for theta, 0 less than theta less than or equal to 2 pi, and you have cotangent theta equals 2 cos theta. So we begin by looking at this and seeing that we have two different trig functions, and we ask ourselves, can I change it to just be cos or just sine or just one trig function? Unfortunately, in this case, we can't. We have cotangent on one side, cos on the other side. So when everything else seems to not work, change things to sine and cos. I can change cotangent to be cos theta over sine theta. And since this is a solve equation, we can work on both sides of the equation. Once you've changed it to sine and cos, how would I eliminate any fractions? Well, I could multiply both sides by sine theta. That'll cancel things out here. And now we've gotten rid of fractions. This next step is the most common mistake that you can make in this question. Okay? Because you really want to get a single trig function, you are going to be very tempted to divide. And any time that you are tempted to divide, here, maybe make this as a note off to the side. If you are tempted to divide, you should factor instead of dividing. What does that mean? How do you factor? Well, you'd have to make one side equal to 0. So I'd have 0 equals 2 cos theta sine theta minus cos theta. And then in these two terms, there's a common factor of cos theta. So you can factor that out instead of dividing by cos theta. Then since you're multiplying here, either cos of theta is equal to 0 or sine of theta is equal to 1/2. Both of those are on your pi plate. When is cos 0? Pi over 2 and 3 pi over 2. When is sine of theta 1/2? Pi over 6 and 5 pi over 6. Were we solving between 0 and 2 pi? Should we reread the question? Yes, we were. What happens if you divided instead of factored? If in this step you divided both sides by cos theta, you would still get both of these answers, but you would miss out on the other two answers. Okay, so that's the first example. Next, we did multi-revolution questions already if you had a 2 theta or a 3 theta, but sometimes you'll want to use your double angle identity to solve instead of multi-revolution. So the purpose of these notes is try to determine when should we still do it as a multi-revolution question that we've done already, and when should we use a double angle identity to help us solve it. So as you write this down, the strategy is if you only have the trig function with the double angle, then you can still solve it as a multi-revolution question. But if you have the double angle identity and another trig function, then you should solve it using a double angle identity. Okay, so only has one trig function. This we've done already. How do we solve multi-revolution questions? You would take your domain, which is 0 to 2 pi, multiply it by 2, so it's 2 times around. Solve for 2x. When is cos root 3 over 2? That's our pi over 6 family. Quadrant 1 and quadrant 4. That's the first time around. Second time around, 13 pi over 6 and 23 pi over 6. Divide by 2 or multiply by a half. Well, this is a review. This is like done so many of these already. Sorry. So you solve for 2x. Is everybody okay with how I got the 13 pi over 6? You added 2 pi to that one, coterminal, which is like adding 12 pi over 6. And then add 12 pi over 6 to 11 pi over 6. And you get those 4 answers. But on the second example, you have a sine 2x and a sine x. So you can't solve it as a multi-revolution question because there's the other trig function. In these examples, you will always first change it to your double angle identity. And just like before, you're going to be tempted to divide here, factor instead, make one side equal to 0. And factor out the common factor of sine. Once that factor is taken out, that means that either sine x could be 0 or cos x could be a half. So from your pi plate, this is at 0 pi and 2 pi. I check my domain. Both 0 and 2 pi were included. So I have all 3 of those answers. And this is your pi over 3 family, quadrant 1 and quadrant 4. Example 4. Solve this equation. 1/2 sine 2x minus cos squared x equals 0 from 0 to 2 pi. So I see the double angle. 3 was the proofs. Oh, that's what we did. Yep. And we did that together. So we see a double angle. We wonder, is this multi-revolution or is this something else? But we have another function. So we're going to change it with the double angle identity. The 1/2 and the 2 are going to simplify. we have a common factor of cos, which we can factor out, leaving me with sine x minus cos x equals 0. So this one factor is easy. Cos x will equal 0. The other factor is not so easy in that sine x would have to equal cos x for that to be 0. Okay? Now, this one is from your pie plate. When is your x coordinate equal to 0? Pi over 2 and 3 pi over 2. This one is on your pie plate as well, and you have two options for solving this one. Okay? You can just think, when is my x coordinate and y coordinate the same? Pi over 4 and 3 pi over 4. No, 3 pi over 4, one's positive, one's negative. 5 pi over 4 is where they're both negative. Or you could say, I could change this to a single trig function if I divided both sides by cos. If I divide both sides by cos, I get sine over cos, which is tangent of x equals 1. Which would also give you pi over 4. Right. So in this case, you can't factor, and I'm dividing by cos, but my solutions aren't where cos is equal to 0. And also, if cos is 0, is sine 0 at the same place? No, so it's not actually, it's not a solution to that mini equation. So it is, we're trying to avoid dividing, but we avoid dividing if when you divide, you get rid of that factor altogether. In this case, when I divide by cos of x on both sides, the cos doesn't cancel anything on the left. It changes it to tan. And when I divide by cos in that mini equation, 0 isn't a solution to that mini equation. Whereas if I divided by cos at the beginning, cos would cancel out, and cos equals 0 is actually a solution to that case. If it cancels something out, then it would mean that cos equals 0, or whatever cancels out, is one of your solutions, so you want to avoid that. So from your textbook, 12, 13, 14, 15, and I've assigned this already when the sub was here, but you wouldn't have been able to do all of these, and nobody started them anyways. But the back of that identities sheet, questions 8, 9, 11, 12, 14, 15, 21, 27, 29, and 31. Which is lots of work. So our plan is tomorrow to use our class time. We'll get our tests back and to work on these questions because they take a lot of time and they're tricky.